Right now, in a mid-sized American city of around 1 million people, the electrical demand sits somewhere between 800 and 1,200 megawatts. That number changes by the hour. It rises sharply after sunrise, peaks in late afternoon or early evening, then falls through the night. The lowest point comes around 5 a.m. At that hour, demand drops to roughly 50 to 60% of the daily peak. In a city that peaks at 1,200 megawatts during a hot summer afternoon, the overnight minimum might be 600 to 700 megawatts. That is still an enormous amount of power, enough to run several 100,000 homes. The electricity industry calls this minimum demand the baseload. It is the floor below which demand never drops, regardless of hour, day, or season. Every appliance that runs constantly contributes to it. Baseload shifts by region, climate, and local industry. A city with large data centers or 24-hour manufacturing has a higher baseload than one built around daytime office work. In most American cities, baseload accounts for roughly half of peak demand. Nuclear plants, large natural gas combined cycle units, and some coal plants run around the clock. They specialize in baseload because they cannot start or stop quickly, and their economics depend on continuous operation. A modern city contains millions of devices that draw power without human interaction. The largest single category is refrigeration. Every home with a refrigerator or freezer consumes electricity overnight. The compressor cycles on and off automatically, maintaining temperature while the household sleeps. A typical residential refrigerator uses 100 to 400 watts when running, cycling every hour or so. Multiply that by a few 100,000 households, and you reach significant numbers. Then there is heating and cooling. In summer, air conditioners continue running through the night to maintain set temperatures. In winter, electric heat pumps and resistance heaters do the same. Even in mild weather, buildings with central HVAC systems draw power for circulation fans and control systems. Electronics add another layer. Televisions and computers in standby mode consume small amounts continuously. Routers and modems stay active. Security systems maintain surveillance. Garage door openers, smart home devices, and battery chargers pull phantom loads around the clock. None of these individual loads seems significant. Together, they define the residential component of overnight demand. Street lighting accounts for 1 to 3% of total electricity demand in most countries. In municipal budgets, it often reaches 30 to 40% of a city government's electricity spending. A single LED streetlight draws 50 to 150 watts. A city of 1 million people might have 80,000 streetlights, consuming 4 to 12 megawatts through the night. Traffic signals add more. Modern LED signals use 10 to 20 watts per bulb, but a typical intersection has 3 dozen bulbs. A city with a few thousand signalized intersections adds another fraction of a megawatt. These systems cannot shut down. A dark street or dead traffic light creates immediate safety problems. Water and wastewater treatment represent some of the largest single loads in municipal government. Moving and treating water consumes 3 to 4% of all electricity used in the United States. At the local level, water and sewer facilities often account for 30 to 60% of a municipality's total energy consumption. A mid-sized water treatment plant serving a few 100,000 people can use 10 to 20 megawatts continuously. Pumping stations maintain pressure in distribution networks. Even when demand drops at night, some pumping continues to keep water moving and maintain pressure. Wastewater treatment plants run around the clock because sewage does not stop flowing. The aeration systems that support biological treatment represent 40 to 60% of a treatment plant's energy load, and they cannot cycle off without damaging the process. Many utilities take advantage of lower overnight electricity prices by filling elevated storage tanks at night. This shifts some pumping load to off-peak hours, actually increasing overnight demand in exchange for reducing afternoon peaks. Supermarkets, restaurants, and convenience stores maintain refrigeration around the clock. Commercial refrigeration uses roughly 1.3 quadrillion BTU of energy annually in the United States, representing about 7% of commercial building consumption. In grocery stores specifically, refrigeration accounts for 40 to 60% of total energy use. A typical supermarket draws 2 to 3 million kilowatt hours per year, with refrigeration running constantly day and night. Restaurants close, but their walk-in coolers and freezers do not. Convenience stores operate 24 hours, keeping refrigeration cases running alongside overnight lighting. Food distribution warehouses maintain temperature-controlled environments regardless of shipping schedules. Even after a grocery store closes, its display cases, walk-in coolers, and freezers continue pulling power. The compressors cycle based on temperature, not business hours. Some facilities operate as intensively at 3 a.m. as they do at 3 p.m. Data centers now consume roughly 4 to 5% of all electricity in the United States, and that share is growing. These facilities run servers and cooling systems continuously. There is no off-peak for cloud computing. In regions with concentrated data center development, like Northern Virginia, these facilities can account for 20 to 25% of local electricity consumption. Hospitals maintain critical systems around the clock. Intensive care units, operating rooms on standby, refrigerated medication storage, and life support equipment draw power without interruption. Lighting, HVAC, and monitoring systems run through night shifts just as they do during the day. A large hospital can consume 5 to 10 megawatts continuously. Manufacturing facilities with continuous processes add more. Chemical plants, refineries, and semiconductor fabrication facilities often run 24 hours. Their overnight consumption may equal or exceed their daytime load. Electricity prices follow demand. When demand drops overnight, so do wholesale prices. Most utilities place off-peak hours between 11 p.m. and 7 a.m. During these hours, electricity on wholesale markets can cost 30 to 50% less than during afternoon peaks. On some nights, prices approach zero or go negative when wind generation exceeds demand. This price structure creates incentives for load shifting. Large industrial customers schedule energy-intensive processes for overnight hours. Electric vehicle owners program their cars to charge after midnight. Water utilities fill storage tanks at night. All of this adds to overnight demand while reducing afternoon peaks. The difference between peak and off-peak prices has widened over the past 2 decades. As air conditioning has spread and daytime loads have grown, the gap between afternoon maximums and overnight minimums has increased. Grid operators match supply to demand in real time, around the clock. Nuclear plants provide steady overnight output. They cannot ramp up or down quickly, so they run at constant levels through day and night. A single large nuclear unit might produce 1,000 megawatts continuously. Natural gas combined cycle plants handle much of the variation. They can adjust output over hours, ramping down as demand falls after evening peak and ramping up again in the morning. These plants often operate at reduced output overnight, rather than shutting down completely. Wind generation complicates the picture. Wind often blows strongest at night when demand is lowest. This can push prices down and force conventional plants to reduce output further. In regions with substantial wind capacity, overnight becomes a period of potential oversupply rather than stable baseload operation. The grid operator's job continues through the night. Frequency must stay at 60 Hz. Voltage must remain stable. Reserves must be available for unexpected failures. All of this happens while most of the population sleeps. The city at 3 a.m. draws half the power it uses at 3 p.m. That half still amounts to hundreds of megawatts. It flows to streetlights and traffic signals, water pumps and sewage treatment, refrigeration and data centers. The machines that maintain modern life do not observe business hours. They run through the night, pulling power from generators that never stop spinning. The overnight load is smaller than the peak, but it is never small. If you liked this type of video, hit the like button, subscribe, and ring that bell so you don't miss the next new release.